Hello. In this video we'll be analyzing the Wheatstone bridge. As you can see, the Wheatstone bridge has a peculiar shape to it, which may make it difficult to identify the loops that you need to acquire your equations, your Kirchhoff's voltage law equations. We will proceed to solve this circuit. The first thing we want to do is that we want to assign polarities to our voltage drops, and we give this one positive, negative, positive, negative, positive, negative, 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 positive, positive. Next thing we want to do is to assign current to each branch. So let's make this branch current I. Then this one would be I1. Then we'd have I2 here. Call this I3. Make this I4. And this I5. Now that we have assigned current to all the branches, next thing we want to do is to assign to write KCL equations at essential nodes. So at this node, we say okay, let's say KCL equations. So at this node, we say that I is equals to I1 plus I2. I is entering, I1 and I2 are leaving. Then we come here and we say that I1 is entering, I3 is entering, then I4 is leaving. So we say that I4 equals I1 plus I3. They will come to this node and say that I3 is leaving, I5 is leaving, but I2 is entering. So we say I2 equals I3 plus I5. Then we'll come to the last essential node here. I'll say that I is leaving. So we say I equals I4 plus I5. And there we have all the KCL equations in the circuit. And the next thing we want to do is to proceed to identifying our loops. Now, in this circuit, we have 4 loops. So the first thing, this would be the first loop. This would be our second loop. So let's call this loop 1, loop 2. Let's call this our third loop, loop 3. Then we have another loop out here. That will be loop 4. Then we can write KVL equations in each of the loops. So in let's say we're writing the KVL equations, KVL. So in loop 1, you say I1 plus 4I4 minus 10. I1 plus 4I1, plus 4I4 minus 10 equals 0. Equation 3, equation 4, and equation 5. Then we come here and write another KVL equation there. So that would be 2I2 plus 5I5 minus 10 equals 0. So 2I2 plus 5I5 minus 10 equals 0. Let's call that the sixth equation. Then we come here and write another KCL equation. So there we say plus 2i2 plus 3i3 minus i1 equals 0. So 2i2 plus 3i3 minus i1 equals 0. Let's call that our seventh equation. Then we come and write for the last loop. So we say minus 3i3 plus 5i5 minus 4i4. So that would be minus 3i3 plus 5i5 minus 4i4 equals 0. And that will be our eighth equation. So we've written the KCL equations, we've written the KVL equations. Then all we just have to do now is to solve the equations simultaneously. So you see, the next thing we want to do is that we substitute equation 2 into equation 5 and equation 8. Now, this will result in us having an equation that is like this: I1 plus 4 into I1 plus I3 minus 10 equals 0. And by further simplification, we arrive at 5i1 plus 4i3 equals 10. Let's call this our ninth equation. Ix. That is our ninth equation. And then when we substitute here, we get minus 3i3 plus 5i5 minus 4 into I1 plus I3 equals 0. At the end of the day, we arrive at minus 4 I1 minus 7 I3 plus 5 I5 equals 0. Then we go ahead to substitute equation 3 into equation 6, and that gives us 2i3 plus I5 plus 5i5 minus 10 equals 0. At the end of the day, we arrive at 2i3 plus 7i5 equals 10. And if this is our 10th equation and this is our 11th, you realize that we have 3 equations that we can work magic with, and with that we can use our calculators to solve further. And by calculation, by using our calculator, we arrive at I1 equals 2.13 amperes, I3 equals minus 0.16 amperes, and I5 equals 1.47 amperes. I2 would then be equals to 1.31 amperes, I4 would be equals to 1.97 amperes. Thank you for watching the video. Please do not forget to like and subscribe. See you in the next video. Bye.